Hi, this is Daniel Ziegler, and I'm going to be presenting my Dots and Boxes project. First, I'm going to show a brief game just to show the program running. As you can see, it gives you the option to enter the dimensions for the grid. I'm going to go with 3x3 now to make it pretty simple, and I'll give the computer difficulty 3. This indicates the number of applies that it searches when it uses the min-max algorithm. The game lets you choose who goes first. Player computer just chooses at random, and I'm just going to go with player now. So as you can see, it shows the grid as asterisks with the numbers in between in the grid. So I'll make a move, put in like 1, 0, and it draws a line there. You need to do column then row, so sort of like X, Y. And the computer will make it move afterwards. So a few more moves here. I don't know, 5, 2. If I do 1, 2, it just closes the box. Anyway, I'm going to stop the program running right now and go over the actual code. So first two things are two enums. I just have an error enum just for the results of actions, and a player enum which indicates whether you're the max or the min. This might be a bit superfluous, but regardless, that's how I coded it. So the model for this program is done in a single node class. The node contains the grid showing the game state, what player is moving, which row and column was changed last, score for the max player or computer, score for the min player, which is the human player. The val is the result of the evaluation function, or whatever got percolated up from lower nodes, the depth it's at, the current paired node, and the list of the children node. I've got a few constructors here, and a couple of get methods. The make move method will make it change to the current node, but won't update anything regarding, say, the depth or value or anything. That is done later. There are also methods to generate the children nodes and add them. The eval is just gets the max score. Updates the making a move always updates the score, and there's always ways to see if things are like surrounded or initialize it to random numbers, check if the game is over, and of course a method to print the node, which is used regularly. This is actually just a method I use for debugging that's going to be removed at the end. Min-max is this is the algorithm used to make a move. The way it works is I used alpha-beta pruning for it since this is the grad requirement. Ultimately, making a move will return an array of 2 integers representing the row and column to be changed. It actually copies the value of the root and then runs it. Now, I couldn't get this working without recursion, so I ended up using recursion anyway, which is kind of anathema when I'm learning about performance. But anyway, it's got 3 different cases, one of which is a leaf node, or it's at the end of or it's at the last ply, whether it's a max player or min player. It'll start with the integer min value to represent minus infinity when it starts comparing these values, and it'll go through each of the children roots and run the same min-max function on them with one less ply and passing in the alpha and beta values that it currently has. So if the value it gets for this is higher than the best value, then it just uses that, and if that value is higher than alpha, then alpha gets set to the best value because that's the highest one we found so far, and whenever beta is less than or equal to alpha, we know we're not going to go down that path, so we just break. And it sets the root value to the best value, which is going to be used up higher, but it also returns that value as well. So same thing with the minimum, with the case in which it's getting the min value. It starts at the max value and just sees which one's the smallest. Up at the top, it'll get the value it's got, go through all the children which have been added now, and check whether whether that child node has that value. And if it does, then it just outputs those coordinates of it. Now the main oh, and as you can see, in the min-max algorithm, it returns those values back up. As you can see, it just gets it whenever it uses the recursive method, so that's how the percolation works. Finally, the main method will output all the text and prompt the player for a move, and then respond with the computer move. If it's invalid, it'll say that, and you can choose all those options like I showed you in the demo. You can examine the code at your leisure at any point later. And that is it for the Dots and Boxes project. I hope you liked what you saw, and I will see you soon.